Yeah. Good afternoon, everybody. Welcome. Today is the last day of the semester for this academic year. Thank you for spending it with us in a lunch and learn presentation that we are thrilled to be hosting. Today's presentation is on shading systems, leveraging architectural engineering design field, and we're thrilled to have two of our alums back with us, Adam and Ben MacKenzie, who are both 2016 graduates of our Master's in Architecture degree. Even the person who serves lunch remembered that. But they have one studied mechanical systems and one studied electrical systems. They went on to work in a large MEP firm, in healthcare and in education industries. After they got their PEs, professional engineering license, they said, oh, this is enough, let's do something different. Maybe they'll tell us exactly how they decided to then found two companies. One failed engineer shading and the other one National Commercial Shading Solutions. My eyesight's not that over there. And I think we'll hear more about what they've been doing with that field. So please join me in welcoming Adam and Ben.
Thank you. So yeah, we'll dive in here, and feel free, please stop us at any time if there are questions. Discussion is encouraged here, and we'll really be taking an approach of just bridging the gap between what we learned on the engineering side and then how much we work with the architectural disciplines now and how effective bridging that gap has been. So
that's the best question. Why two company, not one company?
We'll get into that. It's a there's a very good reason for that.
Yeah.
And then, yeah, so my name's Ben MacKenzie. This is my twin brother, Adam MacKenzie. We are graduates of the 2016 MAE program, and that's been a huge anchor for our success, and glad to be back here.
Yeah. Well, sorry, before we hit the agenda, a quick breakdown of the, like what everyone's studying. I don't know the best way to ask that, but I assume a mix of AE and other programs. Construction. Yeah. What is the split like, design or the AE side versus construction? If you're construction, raise your hand.
There might be something.
Okay. Yes, down at Kiewit as well. Okay, and then if you're like engineering design as well. Okay, excellent. So we'll get into it obviously, but our background is in engineering. But as we talk through this, we'll show a lot of our work today is really on the construction side and subcontracting in particular. But we still use that design and engineering skill set every day. So we'll talk through that. But like Ben said, at any point, raise your hand. Let's just drop something out. We're happy to pause and dig deeper if needed.
Yes. So a brief overview of the agenda today. Intros, really talking through the company history and how we ended up where we're at now. And then we will dive into some project examples and then get into the engineering implications and where we want to really explore and research here in the future. And then obviously we'll end with a Q&A. But before we get in, quick question. And the answer might be fairly obvious. We'll get to it later. But just imagine a room. It's a 10 by 10 office, a square room, all glass. If you're in that room, what's going to be your largest cause of concern for glare and thermal discomfort? So just think on that. We're going to address that throughout the presentation today. And if anyone in here is mechanical, I have the answer for you on this.
All right. So, to the first question, talking about the two companies we have. This starts a bit on the journey, but if you, this is an old sketch. I think we did it in 2018, 2019 when we were coming up with the idea of Vail and one of the companies we have. And if you look at that as the sketch of kind of your general life cycle of the design and construction of a typical building, and that's what we're in every day. You have some stuff with the owner interview, and then the big bubble there in the middle is design and collaboration. That's probably where most folks will live, like coming out of school or day to day. So you have your architect, and then they have a lot of sub-consultants, so mechanical engineers, electrical engineers, that type of stuff. And then you get into some specialty consultants, so lighting designers, acousticians, fire protection engineers. And as we were getting into this, we said, hey, maybe there should be a specialty shading consultant engineer. And then as you move through the construction process, that team issues construction documents, and then you move to the final phase there of the actual construction. And then as we did more and more design, we started to see, hey, there's a need for someone to install some of the shading systems we design. And that leads to the two companies we have. So at first we started Vail Engineered Shading, and that's really a true architectural subconsultant. So we'll be hired by architecture firms, engineering firms, and we'll do full design blueprints, write specifications for mainly interior shading systems. And then as you move through the process, you get to the construction, we said, hey, someone has to install this. So we developed a subcontracting arm. And really that's where we spend most of our time every day, but it's still a very good balance. So that helps set the scene of where we operate, I'd say, in a construction life cycle.
And then finally, putting everything side by side, again, Adam and Ben, but I specialize in mechanical system design. So it was interesting, and we'll get into the story more, the implications of thermal, or the thermal side of glare control, or basically if you have a window and the sun's coming in, we'll simplify it, it gets hot, it gets bright. Yeah. And when we were at Henderson, the old firm we worked at, those concepts kept coming up on projects and we never had a good solution. We didn't, our architects didn't, our energy modelers didn't. And that is really, the backbone of where we're at today. So currently we exist as the largest window treatment contractor in Nebraska. We're around 45 employees now. We've got offices around the Midwest and also a presence in Nashville as well. Currently Des Moines, Kansas City, Minneapolis, and Nashville with our home base being here in Omaha.
And it was on the last slide, but we really do try to focus on having that full design build approach. I assume if you guys have seen stuff on the design or construction side, you'll hear the term design build. And a lot of that is, you want to be a one-stop shop for anything a client might need. And we can really put that into practice. A lot of companies out there aren't design build in the sense of having licensed engineers on staff, issuing drawing specs, stamping them and all that. So we're very unique in this space, in the interior and exterior shading space where we offer that. It's just kind of the natural progression of our careers being engineers and getting into this. So with that said, are there any questions on kind of the background, and then we'll get into some of the fun projects and get more specifics of what. All right.
So
I'm going to take this.
Start with the story. So this is 10 years condensed into hopefully one slide. We've said 2016 graduates, and then when we went down to Kansas City, we worked with Henderson, large scale commercial projects. I did spend a lot of time in design build, but the projects where it came up, I was working on the Oklahoma City Convention Center, and it's a beautiful building, and there was let's say a 500-foot long, 100-foot tall west-facing curtain wall. So when we were designing the mechanical plant, there were huge load implications on at the peak hours purely because of that curtain wall. And now in looking through that, we said, hey, we reached out to the architect and said, hey, we know you have a shading system on this wall. Can we account for it? Can we factor it in just at peak load conditions? And the answer was no, we don't know how to set up those controls. So that happened alongside this discussion on several other projects from the lighting side. And we started working on some research projects that ultimately led to the idea of Vail. So I'll abridge the rest of this year. In 2019, we invested in a residential window treatment company, Budget Blinds, and that was our first foray into, hey, we can start dabbling in the how to build and deliver these systems. Vail was officially launched. We'd been working on it before, but it was officially launched as a brand in 2020. And then in 2021, we landed our first staple project at Joslin Art Museum, which we will dive through here in a second. As we continue to expand through the Midwest and then down into the South, NCSS was launched as a standalone commercial contractor. And then throughout the subsequent years, we expanded to Iowa, Nashville, and then most recently late last year into Minneapolis. So the team's grown quickly, the business has grown quickly, and again, it's all tied together, and we'll share on that as we go into the projects.
Yeah, good main points there. All right. So now a bit more on the specifics of what we do. So we talked about, the name shading is in all our company names, or the term shading, but a lot of what we do is dealing with high-end motorized and automated shading systems in buildings, and most of the time these days that's with roller shades. If we were across the hall, we'd have a great example to point out too. But there's a motorized shades in the PKI 158, I believe. Plenty of them down at Kiewit Hall. But essentially what it amounts to, you have two brackets and then a metal tube that goes between those with a motor inside, and there's a roll of fabric on it, and it spins one way to make the fabric go down, another way to make it go up. And if we look here, there's a section cut on the left side of the screen. This is actually from the Omaha Central Library project, so it just had its grand opening last weekend, two weekends ago.
Yeah.
Very pretty recent.
Well,
April 19th.
19th, yes. So this is fresh off the press here. But this is a detail that we've been looking at since 2023, I believe, through the design and construction process. And if you look at the black text, if that's coming through well, that's on the left-hand side and is calling out what the shade is. So in that whole section cut, it's just a small part of it. A couple of brackets, a tube, and then a motor in there.
Yeah.
And what? Yeah.
So the roller shade itself is an extremely simple component. Even if you get it high-end controls, it's a very simple device. And what really I think we're going to show here is throughout the entire presentation is it's not the shade that causes problems, it's everything around it. And those are the solutions from architecture and engineering.
Exactly. So I won't go through every item up here, but what we're trying to focus on is if you think about what's around the shade, you have your curtain wall, but above it you have metal framing, metal stud framing, wood back. Around or below it, there may be a metal pocket that's enclosing the shade. There might be a drywall pocket. And then certainly on motorized and automated systems, you're going to have line and low voltage wire. The shade may be a line voltage shade, or it might be a low voltage shade. There's going to be power and control wiring going from that. So as you start to layer in all these pieces, you have an architect and interior designer that are going to be specifying your shade. So the architect might pick the manufacturer. So to some extent, is it the Ford or the Chevy? Your interior designer is going to be picking the fabric type and the color. And then you have people coordinating framing, an electrical engineer and lighting designer laying out other parts of the system. So there's a lot of people who start getting involved here. And traditionally, we're a Division 12 system. So that's interior finish. And it's really roller shades as you get to the automated systems and evolve more than just an interior finish. It's really an electrical mechanical style system. So this is, again, not into all the weeds, but we're just trying to emphasize there's a lot that goes into this. And that's what we started to see with Ben's research project he talked about as we got into construction. It's kind of, it turns into a black box at the window head where it's difficult for one person to manage and know all that goes around installing a shade system. And then lastly, on the right-hand side of the screen, that's a screenshot from Omaha Central, or a snapshot from Omaha Central Library, showing before the ceiling was put in, all of those things coordinated in the field. So there's line and low voltage conduits and wiring, junction boxes, wood backing you can see there along the wall. So I'm trying to give a real reference to it.
Yes. And I think summarizing the slide, even though this is like what we build now, what we design is an architectural component, it's driven by the architect. The vast majority of our coordination and really specialized discussions are on the engineering side. So it's a unique system in the fact that there's a huge engineering influence, but the engineer per specifications doesn't really get to influence the system. So keep that theme in mind as we go through these projects. So we'll back up. This is the first design job we did. And at the top of the screen, we have design build resume. Each word will be highlighted depending on what type of service we actually provided on the job. So this was the design contract. And this was, to our knowledge, the first time where a separate consultant was brought in to deliver a set of drawings and specifications purely for the shade. So it's a standalone set. And Vail was hired to do this. It's a 12-story patient tower down with the University of Alabama. And the real reason we were brought in is it's a rehab facility. So there's a south-facing curtain wall there on the screen you can see to the right. And the whole goal of that area is it's a therapy gym and rehab gym. So if you think, hey, we're walking through the space, sun is coming in, if someone has mobility issues, they're going to struggle to put a shade down. Something as simple as that. And if there's a nurse with them, they don't want to leave their patient to go activate the shade. So what we did is we used a fully automated system. We designed special fabrics for this project, special control sequences to say, hey, when someone's in that space, glare will not be a concern. You know, reflecting off the floor, coming in through the window, we're addressing that. So this project, it was a success. It just got turned over. But the interesting part of this, why we highlight this, is when we were hired for this, we didn't have CAD standards. We didn't have drawing standards. We didn't know what a shade drawing should look like because those don't exist. But if you look at the, there's a small riser diagram here. If any of you have done electrical or mechanical design, that looks exactly what we do every day. So this was a fun exercise and a rewarding exercise to go through and say, hey, we get to start from scratch to start our company standards today. So the same standards we developed and used on this job are still used today on projects around the country. The point here is that the proper drafting, proper engineering, proper system layout is something that's consistent across engineering systems and architectural systems.
Yeah, absolutely. Yeah, that's a theme, systems.
Yeah.
We're going to talk about that. Obviously, you have a roller shade system that operates in a building, but the vast majority of our day-to-day job now, which is really more on the running the business and operation side, trying to win projects, it's all about what systems have we developed to turn over jobs like this or to win jobs like Omaha Central Library. All right. Any Husker fans in here? Hopefully a few.
Hopefully they
Yeah, there we go.
So this was one of our first large wins on the contracting side, but we also leveraged our design capabilities. So this is the Osborne Legacy Complex down at Lincoln, or the University of Nebraska Lincoln, their football facility. So when this job came out, Populous led the design, and there were a lot of motorized shades, a lot of special conditions. But what the electrical side of the design was lacking the rough-in details. So basically, we came on, our pitch to the contractor was, hey, we are new in this industry, but there is scope missing on these drawings, and what we can do is help you coordinate it. So the main pitch here was we'll flush out, we're not going to point fingers, we're going to come in, help flush out all of the cross contractor coordination. And on the right, we'll blow this up here, but this is an example of the detailing that we do. And again, it's pathways, it's scope delineation, it's stuff that is consistent across architecture. So on the left of your screen is the original detail for the roller shades on the system. You can see it is a small 5x5 metal box, and it says roller shade. On the right is what ultimately was the final design we worked through with the architect. And you can see there's just, what was missing on the left was there was no electrical or low voltage pathway shown. And it's another thing that we say is a roller shade is not incredibly complex. In the scope we laid out on that drawing and made small changes architecturally to the pocket, it made this substantially easier to phase in construction, substantially cheaper to build, and it made the coordination between trades easy. So that stuff, whether it's architecture, whether it's engineering, that is what we do as a consultant, is to make things constructible and to make things coordinated. So we won't get into the weeds of the detail, but yeah, this job was turned over successfully 2.5 years ago. Yeah. And we continued to work with the owner since.
Another one close to home, UNL Kiewit Hall. So yeah, starting in, I think we were engaged on this in 2021. We started designing and bidding the automated shading system on the job. And that one turned over, I believe, in 2024 is when it opened. And this has a fully automated shading system. Most shades in the building are motorized and connected to a central backbone that goes to a head-end controller that essentially has a 3D model of the building. It knows it's located in Omaha or Lincoln, Nebraska, what direction every shade is facing, and it knows how to position those shades throughout the day to limit glare based on classroom scheduling or various other things. And there's also some rooftop sun sensors that can sense if it's a cloudy day. If it's cloudy, the shades will cease to operate to avoid limit wear and tear.
And I'll pause there.
Yeah.
So again, we're an architectural subcontractor. Everything Adam just talked about when it's in terms of planning the solar tracking, modeling the solar tracking, and commissioning it is purely reliant on your lighting design background and understanding of how those work. So typically most dealers or most subcontractors won't commission these systems themselves. Our entire team's capable of doing that because we understand the fundamentals behind it. It's not a black box. We understand the inputs into it.
Yeah.
And actually, one of our former interns, Jackson, commissioned this building. So, yeah.
So a fun journey for him.
Yes. And then another part, and we'll dive into some of the concepts behind this later. This building, big glass box, this gets back to my earlier slide. And a question that could be asked here is, hey, if it starts to get hot, there are chill beams in the building. So there's an upper limit to how there's an upper limit to how much cooling those can provide per area. What if the shade's shut when it got hot? just a thought there. We'll get into that later.
Here's another local project, and Joslin Art Museum. Has anyone been down there yet? So this has been open for a little while. Excellent. If it was a sunny day, the shades might have been moving depending on when you were there. But yeah, this was Ben had it on an earlier slide, but this was really one of our flagship projects that kicked off our subcontracting arm. And this, I think we were engaged on this in 2020. So it was a very long life cycle in terms of a significant amount of design was required before getting to even thinking about putting a screw in the wall in this building. But this was a unique project. If you look at the top right there, there's a very interesting curtain wall where every there are angled shades, and we'll show more of that off later. But there was a significant amount of coordination and custom bracketry, custom milling that was required for these shades, so they fit and mount correctly. And even some work was done before us with the architect worked directly with the vendor that we ended up providing for this job. But this is one where, due to the custom complexity of the system, there was the engineering who was involved. They had a very detailed control layout of the job and the construction documents, but they're not shade experts. They're not the ones who deal with these every day and buy out the motors. So even though they had a very good control layout and wiring layout, it did not match what we ultimately had to provide to fit these custom windows. So there was a lot of back and forth needed with the engineer, but it was a very collaborative process to get this one across the finish line. It worked out very well. There we go. And here's some photos of the shades. You can see them on the left side operating there. At their peak, they get about 35 feet tall, and then there's a shade that deploys from the bottom up to cover those skylights, and those reach out about 25 feet on a tension system. But the uppers are from the Netherlands, the lowers are from a vendor we use in Spiceland, Indiana. So it really was an international collaboration to get that one delivered.
And when we first interviewed for this job, Adam, I think he was on board for about 2 weeks.
Maybe in the fourth week.
Yeah. We were very new in the industry. When we sat down with Kiewit, the general contractor, we didn't go in and talk about fabrics or what things need to look like, how much things should cost. We sat down and said, hey, the one thing we can tell you, we're a new team, is that we can coordinate this. We understand what the architect needs. We understand what the engineers are going to be looking for. And again, that was all purely from the engineering background that we had. So going in, sitting down with that showed success that we could make the jump over to construction, and it's a universal language. Proper design and coordination is universal across trades.
One last thing.
Yes.
And even digging into having a breadth of knowledge. The last line there. This job does have a fully network shading system. All the shades are tied together. There's solar tracking, different scheduling systems we put in place. But also in certain parts of the building, our shades covered doors. So we had to have fire alarm integrations. So if the fire alarm went off, our shades with drapes would open, so you could maintain egress pathways. And there was certainly some concern from certain folks on the construction team, like, hey, that could be complex. How are we going to get that done? But we came in, we flagged that early on in the project, and it went off very smoothly. So it's knowing about those systems, various code implications, even if you think, hey, we won't ever have to know about a fire alarm system when we're designing shades, may not be the case.
Yes.
So
Everything's tied together.
yes.
Quick note, we were out in Raleigh last week, and this project, Joslin, was awarded at the International Window Coverings Expo the Specialty System Grand Prize. So it's a stunning project if you haven't been there, not just the shades, I'm biased, but the entire architectural construction process of this project. Yeah. Last thing, I love this picture in the bottom right. This was the custom bracketry that you see up on the knuckle, we call it, where the shades meet. So these are custom brackets, custom powder coating on everything. The power for these was brought up through the curtain wall and then out into the system. And I think that caps off the theme with this project and others is, despite being an architectural company, everything we just talked about here is an engineering concept. This might be our last project to show off here, but this is a very recent one. So the new Omaha Central Library, you'll kick it off with the electrical.
Yeah.
I'll jump in.
Yeah, so this was one where there was a split design team where one firm handled the exterior package and then another group handled the interior design. And when you think about that, there are certain implications with the curtain wall or with electrical engineering versus interior design where you may see a scope gap. And this was one where a certain set of references in the drawing were for 120 volt, so line voltage motors. And then in the, on the drawings, it was carried, low voltage motors. So if you're not familiar, there's a very big difference between those two. One of them, there's a lot of conduit junction boxes you need at the window head. The other system, a low voltage shading system, it's all home runs. There's specific low voltage cabling you need that runs from every single shade back to central power locations. So the coordination and even the cost implications for the electrical contractor are very different between the two. So we came in, we were engaged with Kiewit early on this one and helped them coordinate that, get things bought out correctly. And also this project is pretty unique. It had a raised floor system, if you guys have been to the library. And that by doing that, they pulled a lot of the electrical out of the ceiling and put it under the floor. And that also had an implication on the shades because we had to run a lot of our whips under the floor of the curtain wall mullions into the piles above. So there were certain things we had to get. We have 120 volt cables that feed these shades. They had to be metal wrapped to avoid conduit and various other things. So there were code implications there, certain questions that went to the city, and it was a unique process to go through.
Yes. And again, that continues the theme of the majority of our success in the advantage we bring to a project is because we understand the engineering implications of these. And just one fun part, if you've been to the library, second floor, there's a children's reading area. And up on the right here is a custom felt system we designed with working with the architect. And everything in there, from the felt, the way it was cut and assembled, the hangers on the tracks that were custom milled to the custom curved track, everything is custom on that. And that was a multi-year process to put that together. And I think it turned out great. It's a beautiful corner of that building. But yeah, that was one of the more fun systems we've been able to design.
Yeah, it's essentially like a vertical blind system you might find at a sliding door in a house, but built with felt. That's very cool.
Yes.
And the outset of that really was the architects didn't know how to specify it because it's a very unique system, and they sent us a picture from somewhere online.
Different art.
Or they sent us a picture that someone else had done. That hey, can you guys build this? And we said never done it, but let's figure it out. Yeah, we'll make some policy. So it worked out well.
So that concludes the running through the projects. Hopefully you have a good idea of what our team does and where our success comes from, the advantages we bring to a project. So now we're going to go more on the conceptual side about where these systems should be going. And I'll preface this with a lot of people in this environment are used to working with electrical lighting manufacturers, mechanical manufacturers that have some of the finest engineers in the industry. They deal with massive budgets, massive systems, highly complex systems. The roller shade industry, despite dealing with solar and thermal glare, or the solar implications in a building, is very underserviced from a research and technical knowledge side, especially at the manufacturer level. And so just keep that in mind as we go through this. A lot of these are simple concepts that just have not been fleshed out in the industry. So going back to my first slide, you have a glass room. If you don't have shades in it, it's going to get warm. If you put shades in it, what if you could downsize your mechanical system? And now with this, I understand the context of from a mechanical engineer's, if they're stamping the drawings, they have a certain amount of liability, and making a decision off of a theoretical model, I understand the context there. But let's just, think about this for a second. So if you were able to downsize your small office, downsize the rooftop units from a 3, 4, and 5 ton unit down to 3 3-ton units. So basically we're saying, hey, get rid of the peak load, downsize it, right size the system. What would happen? This is a very napkin scratch type calculation, but we say, hey, we'll save $4,000 to $5,000. Well, to automate the shades that you would put in that space, you could do it for cheaper than $4,000 to $5,000. So this is that concept where you say, hey, automating the shades may have bigger implications than just saying, hey, the shades move by themselves.
I guess any questions?
Yes.
Yes. Jump ahead.
And I could sidebar in the slide for 4 hours if one wants to.
Yeah.
So a question on this is that we automate the building partly because we want to keep most people happy, and partly because we need to keep our energy performance the way we want it.
Yes.
From what I've seen from the research world, it seems like we can never automate the building without putting an override switch there. system, our automation system might make a 3-ton unit big enough. But if this system gets overridden, then it won't be enough.
Yes, and that's that part of this discussion, at least from our experience, and I'm not saying like one specific high-end project, but globally across the market, most owners aren't aware that automated shades even exist, let alone that we can lock out controls for a certain period of time, or the fact that they can make the call on this. If the owner of the building wants to say, hey, shades are locked out in a big open office for the 0.1% peak load condition, they can do that. It's their building. But we never even get the discussion to that point. By the time our system's in there, it's far, far past the time where that discussion can be had. And one thing we get into too is just like, even if we're not talking about an overall capital savings and downsizing the system, if your system is set up, you've got the variable capacity in it, why don't you just model this to say if our building's unoccupied, run some sort of a heating sequence in the winter or a cooling sequence in the summer? So, this is more the pipe dream would be a building's design where the automated shades downsize the system and it pays for itself threefold. But it's more the real application of like the small steps you can take to say, if the building's unoccupied, do something with it. You do something with the shades. That's really where I think the discussion normally goes, is we got to overshoot it and then say, okay, there's so much we can do that isn't locking out the controls.
I'm certainly with you on that.
Yeah.
I think this is the main constraint that we present with more and more predictive models that are now very widespread.
Yes, and I think what we talked about this briefly in the past is that when we talk to we've got a lot of friends in the energy modeling world, and everything, they can model shades, they can model fabric, they can model timings. They cannot model when someone goes and hits a switch and overrides it. That breaks the model. And I think that's the core point, is to say, what can you do control-wise? If you average control, if you would analyze controls in a building, average everything out and back up and say, hey, we could make some assumption here. There's so much research. I mean, there's so much that can be done on stuff like this.
Good question.
Yes,
And it's good, very, very valid.
and tied into that, a very similar concept here. Well, again, we'll talk higher level on the slide. So if anyone has done lighting design or mechanical system design, you've done control sequencing. And mechanical and lighting control can take numerous pages of a CD set. And when you look at a roller shade system, which has, from a lighting side, huge implication on how the system's actually going to perform, sequence of operations don't exist. And we've seen thousands of sets of drawings, they do not exist. So that's another part of what we've been working with some key clients, is to say, let us do at least a very high level control sequence, even if it's just how we interact with lighting from a timing point of view. And then obviously getting back to the last slide, something along the lines of a very rough control sequences in the bottom right of the page there, just saying, hey, if your compressor load would hit a certain metric, can the shades be triggered, vice versa.
And this is another thing, going back to some of their earlier concepts about, building a system or starting from scratch a little bit. When we came into this, we both had experience with those sequence operations from mechanical and lighting control sequences. But we said, we've never written one or designed one for roller shades. So we took past experience from doing our old systems and said, okay, if we're doing that same concept with shades, what types of control points would you need? What kind of actions with the shades would you want? And we built out a good number of templates for various conditions on control sequencing for shades. But to Ben's point earlier, a lot of the architects and engineers we work with, if you think about the number of systems they specify in a building, shades are one of them, but they're not equipped. It's not their expertise to list out a sequence of operations for the shades. So on most projects, we literally see a wall switch that says, wall switch with a tag that says shade control, and then you may have a note in a spec that says provide a solar tracking system. But there's so much more that you can do with any of these systems in building.
So this is a massive oversimplification of the concept. If you've ever been in Europe, please pay attention to where shades are in a building. Often they're outside. Obviously, that if you keep the thermal load outside of the building and block it there, you have massive savings. But in the United States, typically we have shades interior of the building, and this detail in the top right is showing you that. Sun comes in, you have energy reflected, transmitted, and absorbed. Anyone from the HVAC side should be very familiar with this. So the real, a lot of times when we first kick this discussion off with mechanical engineers, they say, oh, well, the energy is already inside the building. We have to account for it. That's partially true. Some is reflected, some of it is absorbed. But then more importantly, if you look at this detail on the right, you can control where the thermal energy is going inside of the building. We have a lot of fabrics that have, 0.74 reflectivity. I think I might have an example. 0.75 is one that we carry. So a lot of that can be rejected from the building, but you also can control it from, instead of it being a room load, you can move it to the coil load. So that's one of those concepts as well, where we say, hey, I know your calculation, mechanical engineers will always just ignore shades. They don't exist. We model around open windows. But the concept here is to say, even if we're not going to downsize the system, some considerations can be made to reduce the amount of airflow that you need in a room and contain that load to the coil. So again, oversimplification, but these concepts are not reviewed in engineering right now.
Well, and there are 99.9% of projects they're not considered. And I think a lot of times it's easy to focus on like high-end jobs with all that bells and whistles with automated shading system. But the vast majority of jobs we do, especially on the subcontracting side, most shades we install are manual roller shades. So there's a chain on the end, you pull it up and down. So there's such a huge market out there, and so many, such a high number of buildings where all of the fancy stuff we can do with BMS science and solar tracking systems and tying into lighting control, that just doesn't exist. There's either not budget for it, not a need or awareness from the owners. Yeah. So it's this is on a very small set of projects, but it can have huge implications on the cost side.
And it's more that concept of like the fact that we ignore these systems. I say we, being a former mechanical engineer. Well, once an engineer, always an engineer. But the fact that that's ignored in the industry might not be the correct approach.
So, and a lot of this is about education, and that's why we try to get out, do this, meet with architects and engineers, and show them, hey, there's more to shades than might meet the eye. So I know the text is small here. What the exact words are doesn't matter too much. But this is me putting on my electrical engineering hat. So what's on the left? This is a typical patient room in a project that we have designed and installed shades on. So the left side is what the electrical engineer laid out, and possibly lighting designer. But in the yellow highlights, again, I know it's small. The lower one, it's a junction box wall switch that says shade. So it's for the wall switch. And then there's another junction box at the top by the window, and it says shade motor. So the extent of the rough end that is being drawn by the electrical engineer and then priced by the electrician, so that's design and construction, is one junction box for shade power, one junction box for a wall switch. Now, on the same project, after we won the job, we came in, did our system layout. The right side is what the actual scope is that we needed. So there are multiple junction boxes, multiple runs of conduit, line and low voltage connections, and ultimately there isn't a shaded wall switch. It's all done through a lighting control system, 0 to 10 volt tie-in for lighting controls. So this is really to say this is one room, and look at like how big that difference is between what was drawn and priced originally versus what our system actually needed. So this is where we try to leverage that design build concept to say, get us in early with our veil hats on, our design hats. We can coordinate this. We can make sure the electrician and everyone else involved with it are pricing the right control points, the right rough end, and limit change orders, make the project more successful. So this, to me, it's a very real application of taking what you put on, or understanding what you put on the drawings can matter, and it has like a real cost impact at the end of it. So this went very successfully. Shades worked well. Cool system. So
Beautiful project.
yeah. Just one sec. And on that, so we've kind of talked through projects. We talked through more of the a little more on the engineering side. Any questions on those points?
And if I leave soon, I can't wait like to ask where do you get all that? I mean, all the odds against you, like you're a fresh grad, you know what I'm saying? This is a new business. You're in the Midwest. How talk about the challenge, financial challenge, technical challenge.
Yeah.
You guys came up with this big successful short time.
The financial one is on the next slide.
You have this down. And yeah, we'll talk about that. And that's a piece as we go into that point that most folks, need to get exposure to that. And you don't necessarily learn all of that in school, because when you're coming out as a new electrical intern or electrical designer and an engineer, your job is not to worry about the profit and loss statement of the business, or how are we winning work. It's to learn and do engineering work. And then as you progress as a project manager, and then possibly the company leadership, it's much more prevalent on the financial side. And we kind of had to go through trial by fire to figure it out. And thankfully we started small. It was just the two of us. We just did the design work. So we've had time to build up the team around us, but we'll certainly talk into that more. But really on the technical side, we had to learn construction. We stubbed our toes a few times on that side, but we still knew the general concepts of design, of like what a specification means on a project, what a contractor does versus a construction manager versus an engineer and architect. So that really gave us a leg up as we were getting into it. We were kind of industry adjacent on the EP side.
I would say, when I was at Henderson as a mechanical engineer, you would see guys who have been on the technical side developing their knowledge for 20 years, and they do not know everything. So the amount you need to know in Division 23 is incredible. Division 12 is exponentially simpler, but there's just so much less emphasis placed as an industry on technical knowledge. So many of the dealers, they push fabrics or push what it should look like, where we say, no, if you understand the systems, you can apply them. So, coming from where everything was a challenge to learn on the engineering side, we picked this up rather quickly and just kept the same approach. So we have a slide on it that's there's an anxiety, saying, hey, if I don't understand something, and I think this comes from school, is to say it's my job to understand that. If you keep that concept, you can get into any sort of construction or design adjacent trade. Yeah, so good timing. This, of everything we've done, I think, that text is small, I apologize, but of everything we've done, the biggest, or the only thing we did that was truly new was getting into the financial side of the business. And, when we were in school, outside of putting together rough budgets of systems, we never talked about, what it takes to make a business make money and how that money moves around the business. So we were naive. We said, hey, and again, Vail, design, NCSS, construction. We said, if an architect will give us a $40,000 fee and we only spend $20,000, we make $20,000. Similarly on construction, we said, if my contract says it's $500,000 to deliver this job, I spend $380 on material, labor costs me $20, I make $100, right? That's not how it works. And I know this is huge oversimplification, even, given that I didn't want to bore everyone. But it's very, to get back to your point, no one tells you how to buy insurance the first time you need it. And that your contracting insurance is a completely different policy than design. That was new. Marketing. I had no idea how to market, no idea how to make a website. So you can either hire someone or you can do it yourself. Software. I didn't know how to buy a license either. So you go through this stuff, and it is really trial by fire. But if you start small, the risk is smaller. On the contracting side, though, and this was a surprise, I guess, is just how much you need from a capital side to actually deliver large projects. And now, again, we started small, but as you get to the large projects, the risk exposure on the contracting side is significant. Yeah. But if you understand your scope, if you put together a good proposal, your risk is mitigated. If you want to break any of this down.
Yeah. And we won't go line by line here, but you'll see that, we were dreaming there with that gross profit of $100,000. And then you start to see the red lines after that. So the next 6 numbers there, those add up to $40,000. So then you'll say, okay, we got some more expenses we didn't know about. That means we have $60,000. Well, kind of, because in construction, if you guys are aware, there's a process or a process of retainage. So that's where a contractor may hold 10% of your total contract back to make sure, do the shades work over the life of the warranty? Are you getting your punch list items done? Things like that. So on a job like this, if that's 10% retainage, well, if your net profit is $60,000, $50,000 of that's retainage, and that's held back. So you're holding $10,000 of profit of a $500,000 contract. immediately, let's say after the job. And then there are things, the GC, they call it paid when paid, where the GC, they have to, or when we're, let's say we're invoicing them for $100,000. Say, hey, GC, here's $100,000 invoice. They take that, then they have to go invoice the owner for that. The owner has to pay them for that, and then they pay us. So it can be a 45 to 60 day process from when we send them an invoice to when we get paid. On the other hand, our vendors that we have to pay for the material, they're saying, hey, we shipped your shades, you have to pay us now. So floating that money is a very significant consideration. I don't want to say a problem, a consideration with the contracting business. And that type of thing, once you go through it, it makes perfect sense. But if you're coming in for the first time and the GC sends you a 70-page contract, it looks a lot more like that first example we showed until you go through it. So again, this is really simplified. We're happy to talk more on it, but any questions you guys want to talk through at this point? Otherwise, we can keep on moving through.
Perfect. So that brings us to really the summary slide here is, what the engineering concepts we developed at this program as we started our careers, it was to ask why at the deepest level. And, I think back to the HVAC design class we did, the design competition, where everything was new. And, someone said, hey, you have to lay out a mechanical plant, but just do it at a conceptual level. Well, I hadn't done that before. So you have to dig into that and say, why? Why is something sized the way it is? Why does an architect, what do they consider when they work through a project? And that goes down to everything, even with financials, is to say, why is the contractor doing this? You understand their point of view, you can build a system around it. And then, the theme of it is engineers can build systems, and everything we talked about here, whether it was how to install a project, how to design a project, how to make sure a fleet of 20 vans is getting oil changes on time. Everything's a system. How do you make sure invoices are sent on time? It's a system. So whether it's an engineered system, whether it's just building a system to operate a business, that's what we do.
Yeah. And it's one of the things I'd love to stand up here and say we have a system for everything. We certainly don't. There's stuff we're learning every day. The team's growing, we're getting into new markets, and everything's different. How you deliver a project in Nashville, Tennessee is very different from the labor and contracting requirements in Minneapolis. And that's not something, there's not really a book on that. So to Ben's point, we mentioned it, the curious anxiety. Having or going into anything and saying there may not be a roadmap, but I know how to figure out a problem like that. I think that's the biggest thing that we learned from the engineering backgrounds we have, where seriously it applies to how you get oil changes on a van, or what types of insurance do I need for certain types of projects, and navigating that. So building systems, being curious about things, and digging deeper is a big piece of what we do every day.
Yes, and that's as we look for new employees, if we go through interviews, it's a mix of what is someone's technical ability. You can always teach people, but they have to have a curiosity and an intentionality about looking for a solution to a problem. And if you do that, there's a lot of options out for you in this industry.
Well, and last thing on that, when we hire people, maybe 3 people in our company of 45 right now have done roller shades or window treatments before coming to work for us. So when I did my first job, we did one of our first jobs was a fully automated system at a local office in town. I barely knew what a roller shade was. Like, I knew the concept from that first slide where it's a couple of brackets and a motor tube, but I didn't know what it looked like or how the wiring ran to and from that device. So if you can come and do it and say, hey, I'm willing to learn something, I think there's a lot out there. Both of us never thought we would be selling blinds and shades and running a company on that when we went through the engineering.
And that really concludes the presentation. We always like to leave with a few, kind of future action items. And one that's still on my to-do list to do at some point with the university is to involve the students in some capacity, because we've shown through this presentation, architecture designs this and details this system. Engineering does the roughing for the system, and then a general contractor buys it out and builds it. And I know there's some small projects coming up on this campus down on the athletic side too, that where if there is ever an opportunity to get multiple, kind of a cross-discipline group together to deliver one of these, we are more than happy to be flexible and make that happen. So yeah, that's in conclusion, that closes everything. Yeah. All right.
So.
Well, so much, we can open up for questions now. We have
Yes.
time till 1:15, so 10 minutes for questions. Anyone in the room want to start first?
Where are you headed?
Long term?
I don't know.
Yeah.
No money?
The goal would be, and we've met dealers from around the country, the goal would be, we see a path where we could say we could be the largest and most technically competent, Division 12 contractor. Now, do we want to keep that level, keep the foot down on the gas for that long? That's a question we have to answer. But at least regionally, we want to be the main player here. There are some markets like New York, Chicago, where construction is a completely different animal. But there's, that from a business side, but then more from the conceptual side, some of those, what we discussed about the thermal implications, the control sequencing, is just try to find a way to bridge that gap between, we have the technology for it, there is absolutely no awareness for it. So I would say one of those is the business answer, one's the, really scratching the curiosity itch on.
And ultimately, I want to have a company that people want to come work for, and that's something that is, that's not a P&L sheet, or that's not a wiring diagram we design. It's, having good people around and good systems in a spot where folks can come in, whether they're an intern or an industry veteran, find a path to succeed. So, when we started this, I truly don't know what I thought it would be. If I think back 5 or 6 years ago, I thought, I probably thought we'd be doing the Vail side, where we'd just be doing the design work, because that was our background. And it really pivoted to, that's the small fish right now, and the majority of the company's time and revenue is on the subcontracting side. So, a big pivot I didn't quite expect, but we kept winning jobs and kept building the team, I suppose. So it worked out well.
I'm curious, what are you looking from us in terms of the difference? How do you want us to prepare the different conversations that you're having very often now with AI, business services, falling out? So your ideal candidate for the job would be master of design, a development mind, would be both.
That's a great question.
Yeah. It's hard to explain because, I would say the perfect candidate, if I could hire someone else, would be my brother, but we've known each other for a while. But I think it's the side of, it's hard to quantify that if you give someone a end solution in a blank slate, can they fit it, or can they make something? And, with both the design competitions we did here, that is what we did, and I think that's where the success came from. And it's surprising because we don't have an answer for it. I don't know how to test for that, and I don't know how to make someone successful with that. From what we've seen, it's really someone wants to get there or they don't, and trying to find the motivations and the way to get there is the big thing. Because again, that's ultimately everything we walked through here is that concept of it. It didn't exist for us, and we had to find a way to make it. And when we were back on the engineering side, I think that's where we had success as well, is just to say, hey, I know we're new to it, but set some expectations and I'm going to work my way to it.
And echoing that too, not to downplay what we do, we work on a lot of very cool projects and very cool systems, but technically speaking, if you think about a roller shade and what's going on behind the scenes, even on a full building automated system, a shade has to, it gets 2 signals. It goes up, or I suppose 3, it's up, down, or stop. That's it. So every shade in the building will move up, down, or stop at some point. And even if we think about solar tracking and automation on that side, back in the daylighting class, I think in my master's curriculum, we built an Excel sheet that essentially tracks sun solar position throughout the day. And if you can do that in Excel, translating that to a central controller that knows where the shades are and what way they're facing is not inherently, it's not rocket science. It can be complex. So it's really to say that, to me, the importance is not we don't need someone to come in and invent a new process or a new shade control system necessarily. It's really how can we come in and solve problems every day. And again, like Ben said, it really is at some point saying, hey, are we changing the oil in the vans at the right intervals? Is there a process to do that? That's something that I think an engineering mindset can't solve. And there's a lot, we do more than change oil. But that's one, I think, an analogy there.
I think just people who can come out and build systems is critical. And I enjoyed doing that in school, but I think at the time it didn't click like that is really what, especially in design consulting, is you build and execute systems. If you can do that, you're gonna find success.
I mean, what was with the like based on the character for this like money and business, like how it was the forming of the company, like the financial, like the people, like investor base and the investor squiggling.
The benefit of a design firm is that the capital needed to start is much smaller. So, when we back up to the slide here. The first acquisition in 2019, it was budget lines of Lincoln, Nebraska. And I don't think we really said it. We have a kind of three-angled approach where we have a residential division through that. The cash flow is very immediate. We have a commercial contracting side where the cash flow is good, but it's extremely delayed. And then we have the design side, which is more, the glue in between everything. So with that, when we bought that, we went to the bank and said, "Can we have a loan?" It was that bad.
But even then,
Yeah.
how do you get a business loan?
Yeah.
I'd never done that before.
Yeah.
And it was a process, but each went through that together. And it's the reality of that. At the time, we were still working at Henderson Engineers, so we had a separate job. And it's like, hey, we think something's here. At the time we had won a few projects, and on the subcontracting side, and then one or two on the bail side, and said, okay, there is something here. Bank will give us some money for this. Kicked it off from there.
And one of the big things we don't talk about in here too, it's the same theme, was a lot of these businesses got stood up siloed, like separate, like kind of, hey, that's the easiest way to do it. We need a solution, go. And we've made it's been very intentional over the past few years to start building things to say, hey, if things keep growing, what's going to be the easiest way to have these structured for 5 years? So that was something, that's a topic we love to talk about, but there's usually not a big audience for it. And so, that's a lot of what Adam and I focus on is what we're building for the future to make things work together.
Yeah. And through the Budget Lines channel, so that's it's a franchise network, and we now have 13 territories, 13 franchises with that, and that involves buying small businesses from 1 or 2 person team and implementing the systems we have here in Omaha and Lincoln in those markets. And that alone is very different from running a subcontracting group, or very different from design. But it gets back to that point of systems where, there's not necessarily a book on how to buy a small window treatments franchise, but
the first time we did it, we documented how it works. Said, hey, this didn't go well. What do we fix next time? And then the subsequent acquisitions have gone, were just that much easier. So,
good question.
Did you ever think about doing an MBA or a master's of engineering?
That's my next question.
Yeah.
Yes.
Thank you.
Thank you.
Yeah.
Yes, as we were first starting, now, no, I don't have time.
That's what he said.
I do think, that said, and I don't know what the curriculum looks like now, but I do think there, at least when we went through, there was a lack of exposure to how does money change hands? What makes an engineer get paid versus an architect? How do they win work? And then what does the contractor care about? How do they get paid? And a lot of problems and arguments can be avoided on projects if you understand, if this person's upset and it's because they're worried about losing money, well, if I can think of how that actually changes hands, you can help them out. Or just, you can soften blows, we can say. But I did think about going back for an actual architectural degree, just more out of a personal curiosity. I think less and less about that now. Just the thought of going back, but no, definitely was considered.
How about your work-life balance?
It's improving.
Yeah.
Can we say that?
Yeah, it was very challenging at the start. The first 2 or 3 years was very challenging, and now some of that is self-induced. We actively knew, hey, we're growing. We knew there were opportunities in Nashville and Kansas City nearby, and we did we didn't have much of a go no go process at the start, so that might be a word of wisdom. At some point, build one of those, which we did now. So it was really any job we can find, we're going to take it on, figure out a way to deliver it. So yeah, it was challenging. especially early on, there's new stuff every day, like insurance and all those things, but, you get the systems in place, the people in place.
Yeah.
Everything gets easier.
But yeah, especially that like 2019 to 2021 was difficult. You know,
Yeah.
we didn't have a team built around us like we do now. We have amazing people around us that can deliver jobs.
Yeah.
That was a difficult time, and then you know, there's ultimately the concept of you don't stop working until it's done. And I think, you know, in school you work until your work is done. But then as you get into the start of your career, sometimes that can say, oh, I hit my 40, I'm done. And I'm not saying one's right or wrong, but that was a consideration. It was difficult.
It was a valid question.
Yeah.
Valid question. But yeah, I mean, to echo the thing, we have an excellent team right now. And we were just talking the other day, even 2 years ago, I don't think we had a single project that was delivered without us knowing most every step of the project. And now there's some projects Ben mentions, and I'm like, I had no idea we won that job. Or delivered it. It's like, oh, that job's completely done. So it is, you know, it's part of the journey. So it's a satisfying part as that comes together.
So looking back to our students and what you studied back then, do you think it would be beneficial if students take classes in business, like a minor, whether they want to go into their own businesses or not?
Yeah, possibly. The hard thing that I don't have perspective on is like, would knowing that ahead of time helps me, like certain things in business? Because I do think the AEC industry, so architecture, engineering, construction, is at the end of the day, it's a business, but it is unique in terms of the role every group plays. And even like a subcontractor, we're in a very different position than a general contractor that we work with. And our design firm is very different financially than the subcontractor or the finance or the residential firm.
Yeah.
But
Well, I would say at least from coming through or in the industry on both sides now, the contractors talk about money constantly.
yes,
Like general contractors, you know, everything is you're losing me money. On the AE side, it's much more of a taboo subject. And I don't mean like people's salaries. I mean like what is our firm making? How are they making money on a job? And so whatever kind of exposure the construction side gives to that, I think there should be. I do think it is too taboo on the AE side where people just don't have I don't want to say skin in the game, but just an understanding of like, hey, my work, I'm billing money to a project. What's my client need for me?
so yeah, is that necessarily a like business school concept? Maybe, but even if it's just more of a generic, how does money transfer hands in the AEC industry? I think it does help understand where everyone's role is. And even if you go to, you know, if you're in lighting, if you understand how a lighting or an electrician or electrical contractor, how their financial situation is, that helps understand like players and who's asking you what throughout the project. That's a good question. Yeah.
Thank you, gentlemen,
Yeah,
so much for
absolutely.
your presentation.
Thank you, everyone. So, and we will be around for a bit if anyone has additional questions, but be respectful of everyone's time. So thanks, everyone.